Hey everybody, welcome back. It's Dave Hoelzer again, your host for Dave's Python Fails, or more generally cybersecurity stuff with Python and other kinds of things. Nice to have you back in this live stream this week. Before we do get started, I do want to mention to you that I have a link that you folks had been asking for. You had wanted to know, hey, could we get a copy of that training data that you were using in those last 3 episodes, those episodes where we put together that autoencoder and we're able to find something that can tell us, hey, is this TLS or HTTP or really anything we want it to, and can act as the basis for real-time anomaly detection in our network. So I see Steven's posted that out in the chat there. I'm also just going to put it up here on the screen. Let me just create a notebook here. We're going to be, whoops, that's the wrong button there. We're going to be creating a little bit of a something today that's related to a question that someone asked in an earlier live stream. You might recall, those of you who've tuned in for all of them so far, you might recall that in the second episode, when we were just getting Zeke talking, we were doing a little bit of the translation of the data, someone said, hey, couldn't we do this with a decision tree or with a random forest? And my response at the time was, no, you can't. Now, that doesn't mean that decision trees and random forests aren't useful. They absolutely are and can be used for a lot of things, but they're really not well suited to anomaly detection. So what I promised I would do in that live stream was take a little bit of time and actually do a live stream trying to solve a problem or two using a random forest. So that's what we're going to do here. We're going to begin with a decision tree, kind of the junior version of that, and then the random forest, talk about the difference between the two. Now, as we go, feel free, if you've got questions or thoughts, just throw them in the chat there. And I'm also super interested to hear where you folks are located, where you're tuning in from. I'm, of course, out here in New York. I'm on the far end of Long Island. I actually sit off the end of Long Island on a little island out there. Where are you from? Where are you tuning in from today? To get started today, though, I am going to, let me just put this in its own cell, maybe make that a markdown cell so it doesn't try to execute it. So that is the link for where that is. And I will also put the data and the notebook we come up with today, I'll put that out in that repo as well. And we'll kind of form this habit that whenever we write some new code, we'll just drop it out there. So if you have questions or side things, let me know. Maybe we'll get that in there too. In any event, we want to start by getting some data in. And actually, let me show you what data I have for you today. The data is located in this content directory I've got here, and I've got some sample data for a variety of different kinds of network activity. So I see some hellos coming in there. Hey, Abdullah from Bahrain. We've got someone from India, Ankit, Chile. We've got Mexico City. Good to have all of you. Very international flavor. I'm very, very happy about that. And Great Britain, nice to have you, Petter, and United Arab Emirates. Awesome. Very, very nice. So thanks for tuning in. So this data here, it actually is in the same format as something we've seen previously. In fact, if I open one of these up, you might look at that and say, ooh, that does look a little bit familiar. Hey there, Mohammed from Estonia. Nice to have you. In looking at that, if you've tuned into the other live streams, you'll recognize this as the same kind of data as we were producing out of Zeek using Broker and then collecting with Zeek. And it is, it's the same kind of stuff. Hello there from Nigeria, Chioma, nice to have you. The data here is just more complete because the data we were working with last week only had TLS in it. This has a whole variety, NTP, QTLS, we've got SMB and Kerberos, a whole bunch of different things. And I wanted to use a little bit more training data this time because we're going to be trying to do a multi-class classification problem. Can we distinguish one from the other? Hey, nice. Oh, we finally got someone from the US. Nice to have you. Is that Tawan? I hope that's how you say that. And Ephraim from Calgary, nice to have you. So this multi-class classification problem is something I can absolutely do with a deep learning neural network. And personally, I will usually use a neural network to solve it. However, it also lends itself really well to a decision tree in a random forest. So let's go down that path because that's going to get us to a point where we can understand why it's not a good fit for anomaly detection. So to get things started, let's just load in a couple of our dependencies here. We're going to need NumPy, I believe, and I think I'm also going to need to use OS because I'm going to be getting some files out of a directory. Oh, we got another one from Texas. Hey there, Lily. Nice to have you. You may have noticed while I was in this directory that I've got this content directory, and then inside of it, I've got all these files. So I want to get all of those files. I want to load all of them in and grab their data. So let me just write maybe some code here. I'm going to maybe define a direct or a constant here, and I'm going to define a couple of functions. How about get file list? And I'm going to use that to return os.list here. So let's just leverage what's built in to pull out the path. That'll allow me to, for instance, get file list, to get a list of all those files. And I can see that IPython, oh yeah, that one's going to cause some trouble to me. So you know what I'm going to do? You're not going to see this, but I'm just going to open this up on my, my Windows Explorer. So give me 1 second. I made the foolish mistake of using Jupyter to browse into that directory. And that's a bad decision because when I do that, it is automatically going to create that checkpoints directory. And that's not going to be so good for us because I don't really want to try to iterate down through that as well. So let me just get those out of there. Okay. So at this point, it should be that if I run that again, yes, that has disappeared. So let's get that out of there. I shouldn't be browsing around in my data with my Jupyter anyway. Hey, someone from Morocco. Nice to have you, Anas. All right, so we can get the file list. Let's actually define something to get the data out of the file. So how about get file, and that's going to take a file name as an argument, file name. And remember, your job in this live stream is when you see me headed for a Python fail, please try to save me. So if I'm mistyping things, let me know. I'll see if I can catch it. I might miss you typing it initially, but that's okay because when I actually do fail, and I know you know I will, then at least it gives me the opportunity to know or come back and look at your text and see what's happening. Hey, so Tawan's got a really interesting question here. What's the best language to learn in cybersecurity? I avoid questions like, hey, what's the best? But I would really recommend that you take time to learn Python. Yeah, I agree with Hadi there. Because when you get right down to it, Python is a general purpose programming language, which means I can use it for more than just cybersecurity. But it is also the language that's used by the majority of open source cybersecurity projects these days. Now, that's a big change. You go back 10, 15 years, and it was other languages. Things like Ruby and Perl was still popular, but Python has really taken hold in this space. So I'd really recommend Python. In fact, a good friend of mine, Mark Baggett, he has written a phenomenally good Python class that SANS offers. It is tuned specifically towards cybersecurity. And I'll tell you what, if you sit down and you work through everything that's in that class, you can go in with zero Python knowledge, and you are going to leave able to solve just about any problem you face using Python. In any event, getting back to what we're doing here, yeah, it sure is. It's very, very flexible. So I want to open up these files here, and I'm going to read them as F, and let's see what I want to do. Let's return. Well, I could just return the read lines from that, but I'll tell you why I'm not going to do that. Because I could end up having, like new line characters floating around, and maybe there's some white space before or after the text. So rather than just returning the read lines from it, I think what I'm going to do is strip the data f.read lines. So what I'm going to do is strip that data just using this list comprehension here. Let's see, all new. Oh yeah, that's true. Is it Michael, do you go by, or Michelle? I know it really depends where you are in the world. It's absolutely true. Software-defined networking is all using Python. You'll find it's actually under the hood of a lot of things. All right, so that list comprehension there will just strip out any kind of padding that's floating around. And hopefully what that will do, let's maybe try to run this. How about we do a get file using get file list sub-0. So let's get the file list and try to get a file. And we've got an error already. So let's see what I've got wrong here. File not defined. What did I do here? For fn. Okay, let me look at where the error is. f.file get file list. File not defined with open file. Oh, I typed file here, but the actual name of this thing is file name. And you guys, none of you helped me. I'm sure some of you saw that was wrong. Let's see what else I've got wrong here. Different problem now. Different errors are good. Content slash, okay. So notice here, I've got the slash content and then boot service discovery protocol. So I can fix this in one of two ways. I could either put the slash here, or, you know what? I think I'm going to stick it on my constant. I think that makes a little more sense. But with that done, we are now able to retrieve files. And you can see that it's returning to us a string of characters. These are those hex values. All right, so let's get my test code out of there. Great. So we are now able to return files. Now, there's something else I want to address. Right now, these files all have that test data, but are all of the strings in those things the same length? Now, with a decision tree, this is a little less important, but generally in machine learning, you really do want to make sure that things are all the same size. Make sure they're the same length. So I think what I'm going to do is just create a function here that I'll call normalize strings. And I recognize I actually kind of complained about this myself. So in that 595 class that's on applied machine learning, I point out that many people who are working with machine learning will lazily call it normalizing when it's really not that. It's really that they're scaling things. Well, I don't mean it in the sense of changing values here. By normalize, all I'm really implying in this case is I'm trying to make them all the same. So I'm going to call it normalize, even though it's maybe not the best possible name to use. And we're going to be passing in a string here. And let's see here. Okay, there we go. And what I want to do in here is say, now let's set a length here. So I'm going to say the length is going to be 32. In fact, you know what I'm going to do? I'm not going to put that there. I think I'm going to make that a parameter in here. Let's set this to be length equals 32. This way, if I want to use this function somewhere else, I can change that value. Because what I want to do is set a standard length for these things. And if the string is less than 32, I want to pad it. But if the string is longer than 32, I'd really like to truncate it. All right, now I got a question here from, is it Madav? Hi to everyone. I was looking for a master's in cybersecurity with machine learning. Kindly provide me which university is best, and I will appreciate your response. Well, I'm going to tell you the best graduate program that you can find in cybersecurity is the one that's offered by sans.edu. So I'd head on over there. But I will tell you that there is currently no focus in machine learning. Since the 595 course is so new, we're not yet at the point where we've written certifications for it over at GIAC, but that is, I believe that is underway. And as soon as that's done, we are absolutely going to be adding that as an elective, and possibly within the next year or so might consider creating some kind of a focus in machine learning and applied data science. We'll see what happens. So that's really where I'd point you today in learning practically how to do it. I know there's other courses or other colleges that are running machine learning sorts of things and offering degrees, but I'll tell you the big problem you're going to find is that the majority of them tend to be very theoretical. So they're going to be focused on, here's the math behind it, and let's implement this. And so you're going to write a machine learning library. But what you're missing in that class is, how do I take the problems that I have in the real world and translate them? That's a super hard thing to do. Well, I mean, it's a super hard thing to know how to do based on the class. That's actually what 595 is about. Oh, yeah. So Hans taught, yeah. So what Cyber Defense was just posted out there, the 595, it actually solves that problem. So I'd point you at that, even if you're taking a degree in machine learning. Anyway, back to my normalization here. So I want to make sure that it's long enough. And if not, I want to pad it. If it's too long, I want to truncate it. So let's deal with those problems. So let's say if the length of the string I was passed is less than, well, how about it's greater than or equal to length. So if it's too big, let's return the string up to length. So we'll just use a slice there, and we'll get up to that length. And I'll deal with it being too long first because it's super easy to truncate it. Now let's deal with the thing is too short. So let's say return string. And what I want to do is left justify it. And that's an arbitrary choice. I'll explain that in a second. And I'm going to pad it with zeros. So I have left justified. What that's saying is if the string is too short, it is going to make it longer. In fact, let me run normalize string. And let's pass it, well, let me not do that. Let's pass it 3 ones. And when I do that, you can see that it has stuck the ones on the left and then left justified and then padded it out to the right. If I wanted to, for some reason, I could also right justify that. So that means that the ones are on the right now and it pads it to the left. With the problem we're working on, it really doesn't matter which one of those I do. So I'm just going to stick with left justified because I kind of prefer it left justified. And I'm going to put my extra padding off on the right-hand side, off on the end. All right. So at this point, I've got a couple of utility functions in place. I'm able to get the list of files. I'm able to get the data out of the files, and I could normalize the data. But there's another thing I'd like to do. Right now, that data is just ASCII. If you remember, when I pulled it back in, it was just a string of ASCII characters. So what I'd like to do first is turn it back into bytes. Because when I run my decision tree, it's going to be very difficult for the decision tree to kind of figure things out. If I just pass it a big long string, it's not going to be happy with that. So let me return or give it integer values, the byte values as integers. So let me write some code to do that. Let's create another function. I'll say that it's ASCII to integers, because that's what it's going to do. And it's going to take in a string. And let's see what we need to do here. I'm going to be returning a list of integers. So let me create maybe int list as an empty list to work with, and I'm going to populate that as I go. Maybe not the most efficient way, but I'm kind of, feeling my way along here. Usually what I'll do is create code that works, and then if I need it for more things, I'll come back and I'll make it more efficient. Now, I've got that list there. Let me now work through the string. It's tempting to try to work through that list with that string with a list comprehension, but I'll tell you why that's not a great choice here. Because look what I want to do here. I'm going to say for I in range 0 to length of the string, comma 2. And that right there, that comma 2 is the reason the list comprehension is not a great choice. You see, right now, my data is coming up as pairs of characters that represent hexadecimal bytes. Well, I want to take both of those characters and turn them into a byte. I don't want to go one character at a time. I need to take them in pairs. That's going to be challenging to do with a list comprehension, but with a for loop, that's a pretty simple thing to do. So let me say that the integer value is going to be equal to, make this an integer, whatever I get out of this. Let's use string sub I. So let me get the value from a position in the string, and I want that value and the next value. Now I'll tell you, it is a common, or would be a common mistake to write that, but that's not going to work. And looking at it, there's a thing about Python slicing that's always been just a little weird to me. So you tell it where to start and where to stop. The start value is inclusive, so that will start at offset I. But the end value is exclusive. In other words, it's not included. It stops one position before that. So if I said string I colon I plus 1, that's just going to get the character at string sub I. That's not what I want. So let me make that plus 2, because now it's going to get that one and the next one. Now, so far, this is asking it to convert that string into an integer, but I might have like A0 or BF or something, and it's going to complain. It's not going to like that. So I need to tell it this is base 16 data. Now it's going to be much happier, and I can just add to int list. Let me append ival. And let's see. So that really ought to do it. I'm going to return that, though, as a NumPy array, because in the end, we're going to end up dealing with it as a NumPy array. It's going to make it easier to manipulate. So I'll just directly convert that here. And with that done, let's try it out. ASCII to integers, and let's pass it a string. Let's say 1, 2, 3, 4, FFAA55. And I get back, look at that. I get back those things converted to decimal and then made into integers. That looks pretty good. I think we're in a good place here. Now, listen, before I go on more, I want to just mention that if you're finding this interesting, you're liking this stream and the things we talk about in the stream, please take a moment to click on the like button, click on the subscribe button if you're on YouTube, or if you're watching us on LinkedIn, maybe click on the follow button so that you'll be alerted anytime any of these are going. And those likes will matter, because then other people, they're going to be able to see this stuff too. Also, if you have colleagues who are doing this work or you think would be interested, please send them our way. We'd really love to have them. I also have another question for you. I have an idea. I actually submitted outlines that go for a couple of months for what I'm going to be talking about in the live stream, but I really do need your help, because I want to make sure that the things we cover in the live stream are things you can use. Now, I'm not going to cover every topic people propose, but please, if you've got an idea for something we could cover in a live stream, something you could use, or if you've got a question that might make the kind of the heart of a live stream, please stick it in the chat. I'd love to hear that. What ideas do you have? What kind of things would you like to learn about? Stick them in the chat. We'll see what we can talk about. In any event, now that I've got that done, let me do one last thing. Let me create a function here that is going to kind of put this all together and allow me to have a single call I can make that will take a string and turn it into all of this stuff. So it's going to normalize it and then return the bytes back. So I'm going to define that as content to features, and that's going to accept some content string. Whoops. And let's make this simply return ASCII to integers, normalize string, content string. So I'm just laying those together. Of course, I don't have to do it that way, but by doing that, it makes it easy to use content to features in other contexts and just pass it in data. So let's use the trick we used before. Let's get file list. Let's get the 0 element of that. And let's get the 0 element of that, the first thing in that string, and that works. So now I'm able to process that data correctly. That means then, I think we're ready to load all this stuff in. So let me make this all data. I'm going to make that a list, and I'll say that for, and remember, the file names represent the protocols represented. And this is a classification problem. So I'm going to try to figure out, or get the random forest and decision tree to figure out which protocol is it. In order to do that, I have to have labels. I have to know what the ground truth is, what the reality is. So let me say that for protocol in get file list, and that should return to me a list of those file names, each of which is a protocol. Let me say for row in get file protocol, so that returns to me the array of all of the stuff in that file. So now it's an iterable. So let me go through each row in that. Let's say I'm gonna form this into a string that has the label on it and then has the data on it, all put together. So I'm gonna create that as a string that looks like this. String equals, and I'll say the protocol here, and then I'll have, now for this, I'm gonna use the comma with a join. And I know this can look a little weird, so keep paying attention to what's happening here. Notice I'm starting it with an F string, so that means anything inside of the curly braces, those things are going to be calculated. They're going to be processed. So this is going to interpret the protocol for me, pop that in there. And now here's another curly brace, so I can actually stick another one at the end. So it's going to run the stuff in the middle as code. So here I've put a string, comma, dot join. So the string class has a join method, and I can use it to join some function together. So I'm going to have it join for me the result of, sorry, I lost my cursor there. The result of running a map against the string, running str against content to features against row. Let's see. And I feel like, yep, I need a couple more closing parentheses. Okay, so now what does that all mean? Let's just take this apart. So the map function allows you to run some function against every element in an array or a list. So that's what this does. It's going to convert every value in there into a string, and those are all joined together using commas. So that's what that hunk of code is going to do. All right, so with that done, let me see where I am now. Let's think about this. So that means that it's currently now one big string. And next, I'm going to yank it back apart. So let me turn that back into data is going to be a NumPy array of string.split. And I'll tell you, what I'm doing right here is very messy. Oh, notice that my color is wrong. So there is a Python fail in the making. It's because I used an F string here and failed to terminate it. There we go. All right. So that's going to convert this back into a NumPy array. Now, hopefully one or two of you are on the live stream looking at that and saying, you could do that a whole other way. I could. I don't want to complicate our lives, though. I mean, I guess I'm complicating our life in a way, but I don't want to complicate it by getting into how you horizontally stack and vertically stack and what the axis means and NumPy arrays, because that could be a little bit confusing. I mean, we cover that in the classes very, very clearly, but for now, I'm going to use this kind of brute force method to take my data, turn it into a string, and then pull it back apart as a NumPy array, even though it's not the fastest, most efficient way to do it. But it's a very direct way, a very brute force way to do it. All right, so now that I've got that, what I'd like to do is all data.append data. Let's add that on there. And let's see here. So where am I? Oh, hang on. I feel like this is scrolled over. Is it? For protocol and font? No, I guess it's not. Okay, so I think we're about ready to go here. let's then say training data and labels. Let's set that equal to a NumPy array of all data. And let's cross our fingers. Well, it didn't just blow up, so that's a really good thing. While that's running, and it's got to load in all those files and do the conversions, let me just start doing data and labels. Let's just grab the shape of that thing, have a look. Hey, it looks like that worked. So I was loading in the data that was 32 characters or 16 bytes. Okay, so you see the comma 17 there, 16 bytes, and then I added the label to each row. So that's the 17. And I've got over 500,000 rows of data. Fantastic. Let's take our data now and let's shuffle it up a little bit. So NumPy has a nice feature in here under random. I could just use shuffle. And unlike many of the functions that we use in NumPy, this one is an in place. And I don't need to specify that. I can just use an np.random.shuffle. And I'm doing that because that's going to make it so that the protocols are currently all together. So this is going to kind of shuffle them up, just like shuffling a deck of cards. And that should be good because I'm going to want to create a test set and a training set. I want the test set so I can see whether or not the thing works. So let's create a split for that. I'm going to say the split size is going to be the length of training data and labels. So let's take that length and let's do an integer division against that and of 2. So let's just split it right in half. Now, I could have gotten away with not doing an integer division because it's 266 here, but let's just do the integer division. I might want to change that split some way later. This way, it's always going to be nice and clean. And then let's say that the raw X train, so the data for training is going to be training data and labels from, let's see, what do I want to do here? Up to split. So from 0 up to the split value. And this is the X train. So the label is in the 0 column. So all of the rest of the column, so 1 colon, that's all the rest of it. And that also implies that the training labels are going to be here. Training data and labels. For some reason, my keyboard is a little sticky today. You may have noticed I'm finally out of my cage where I was kind of stuffed in the corner over there. So, hopefully this is a little bit easier to see and hear and everything else. But it's a different keyboard, so it's a little tacky here. This is going to be again the same stuff, but now only column 0. Let's copy that just to save some typing here, and let's change this to be raw X test and raw Y test. And let's change our split. So it's no longer going from 0 to split. It's now going from split to the end. And the same thing here. So let's just change those two. Run those both. And we've got some problems here. So split is not defined. Oh, I called it split size. Let me just rename this because that's going to be faster than fixing all of those. So there we go. That looks pretty good. Now, that should mean that I've split my training and my test data up. But I'll tell you, I do have a small concern. Here's my concern. Is it possible that I have types of data in my test set that don't appear in my training set? We're testing for a bunch of different protocols. Could I have inadvertently left some stuff out? Because we just shuffled it, right? So how could I find that out? Well, we could do something like this. Let's use np-unique against raw Y test. So that's going to show me all of the unique values that show up inside of that array. And I could also look at np.unique for raw Y train. All right. And I could compare them, right? But I think there's a simpler way to compare them. I think what I could do is something like this. Let me assert that the length of NP unique of those, so the number of things in there should be equal to, not sure what happened there, should be equal to the length of the NP unique of that. That should be true. If it's not true, it's going to throw an error. So I don't need to do an if then, I can just assert it. And if it's not true, so if I resplit the data, reshuffle the data, and it was no longer true, it's going to stop execution. So I realize there's something wrong. All right, so I know then my test and train data both cover all of the different classes that I have. Perfect. Let's then grab what our labels are. Our labels should be np.unique, and I don't need to run it against both of them. I only need to run it against one because I know they both have the same stuff in them. Let's see, what do I need to do here? I think we're really ready to do the decision tree. Let's try it out. So the decision tree we're going to be using sklearn. Now, I don't know if you know this, but just yesterday, Kaggle released the results of their 2021 survey. They surveyed 25,000 machine learning folks or data science folks about, what libraries they use, what machine learning solutions they use, all those kinds of things. And interestingly, the top used package is sklearn. Now, that really surprised me, although in thinking about it, I think I understand why that is. On the one hand, Kaggle is mostly going to be researchers and folks in academia and hobbyists, rather than people who are solving commercial problems with machine learning. So that's one part of it. But then there's another. sklearn has a pile of things that you're not going to find in things like TensorFlow or PyTorch or other kinds of libraries. For example, things like decision trees. Decision trees are still very, very useful. Support vector machines. They are not found in TensorFlow or PyTorch because those things are really designed toward neural networks, whereas these are more traditional statistical and mathematical learning models, and sklearn supports all of them. Do you use sklearn? So that's my question. How many of you are using sklearn or have used sklearn in the past? Would you mind just putting something in the chat? Do you use sklearn? Have you used sklearn? Are you familiar with it? Let me know. I'm kind of curious. It might be worth maybe a live stream that talks about some of the different capabilities that are in sklearn, some of the kind of nooks and crannies that people aren't generally aware of. But in any event, to make use of this, let's import from sklearn tree, import decision tree classifier. And I have to be careful. I always misspell that one. So that's just going to load that in. And now I can start creating one. Creating the decision tree classifier couldn't be easier. Of course, you can look at the help for it because there are decisions you can choose to make, but I'm just going to use it as default. Some of the things you can do are changing, for instance, how it's going to do a split, how many things have to be on each side as it's making the split. You can do things about the depth. I'm not going to make any changes. I'm just going to use it as is. I will say tree equals decision tree classifier, and then let's create it. Let's fit it. So tree.fit. Now, if you've done some work with this or with machine learning of almost any kind, you're familiar with this fit predict pattern, or in some cases, fit transform. It just depends on what you're doing. But this one here is the fit predict pattern. So I need to pass it in the raw X data. So I had raw X train and the raw Y train, because this is a form of supervised learning. So I pass it both the training data and the training labels. And if all goes well, it looks like it is, we now have a decision tree classifier that has been designed or solved that problem. Let's make some predictions with it. So to do that, I'll say my predictions will be equal to tree.predict using my raw X test data. That's it. It's done. So what does it look like? Well, the output of that are that's not the predictions. I meant the predictions there. The predictions are predictions. Did I spell that wrong? Maybe I should just try that again. Predictions. Oh, you know what? I see my problem. Apparently, I inadvertently hit a hotkey that changed this from code into raw data. So let me run that and then try predictions. That looks better. And you can see I now have a list of predictions coming back. Okay, that's pretty cool. But how accurate is it? Does it work? Let's create a little function for ourselves. Let's create evaluate, and I'm going to pass that in y and y hat, or ground truth and predictions. Y hat is are our predictions. That's sort of a convention we get out of statistics. So let's say that result is going to be equal to a NumPy array that is a list comprehension where y sub I is equal to y hat sub I for I, comma, nothing in enumerate y. So let me explain the logic that's happening there. Let me explain what I'm doing. What I'm trying to do is create an array that has either ones or zeros or trues or falses for every instance where y is equal to y hat. So I'm trying to see where are these things the same. Now, the way I'm getting that is by iterating over them for I in that list. But see, I don't actually want the value that's in Y. I don't want that. What I really want is the index. So I'm using the sub I, and I'm just dropping the value that gets returned for Y. You could write this list comprehension in other ways. I've just chosen to write it like this. And by doing so, it gives me this array that has either trues or falses or ones and zeros. So let me do f.accuracy is going to be results.mean. Now, the reason I can use the dot mean is because I made it a NumPy array and multiply that by 100.0%. Right. So there's our function. To use it, let's call evaluate using raw y test and predictions. And it says 99.79% accuracy. Wow, that's pretty good. But now let's take a moment and answer that question, because I believe the person who asked me, their name was Mohammed, and they said, could I use the random forest or the decision tree to do anomaly detection, to find unknown protocols? And the answer is no. But why not? Well, here's what it comes down to. We have now created a decision tree, and that decision tree is very, very good at figuring out what the protocol is. But it can only give us an answer that is a protocol it has been trained on. What if I give it something it has never seen before? It's still going to give me an answer. Let's see if I can force it to do that. So let's create a string. Now, I'm supposed to have a string that's 32 characters long. So how about, let's see if we can just create this. So let's say we're going to have 0 through 9, 8, 9. Let's just use those. And what I want to do is, well, you know what? I'm going to make this easier. Let's just create some data. 8, 9. I was going to make something more complex. I don't think I really need to do that. Let's just paste this in. So I could even paste that in again. So I've got more stuff than I need. What I'd like to do is pass that in or try to do a prediction on that. To do that, I'm going to need to run content to features on that, which gives me back my array. Now let me just check here. Is that right? Is that what I'm actually passing in here? You know what? Let me look at x test sub x raw x test sub 0. So it should actually be an array as type. I wonder what that is. I haven't actually used that type. So feel like it's not going to like that one. Let's just see here. Yeah, that's not going to work. So let's do as string. Is it capital? Or no, it's str. There we go. Let's see. Yeah, okay, so that'll do it. So let's convert them to strings. There we are. So they are now the right thing. Let me capture that somewhere. My test is going to be that. So my test, it currently has this shape. That's not quite the right shape. The shape I want it to have is going to be as though I'm passing it in as a batch of data. At least I'm pretty sure it's the wrong type. Let's just try it. So let's try test or tree.predict against my test. And I expect this to fail. Yeah, it's not going to be happy because the shape of that is wrong. It doesn't like the way it looks. Reshape your data to be -1, 1. It doesn't like the shape of the data. So let's try to reshape this. If I reshape it as a -1, 16. All right, so it makes it an array of that stuff. So it's just making it into an array. So let's reshape -1, 16. And now I get back a result. And the result I get back is, it says, that's Kerberos. Listen, you and I can both look at that, and we both know that's not Kerberos. That's just random junk. So it has no way of telling me, hey, that data isn't valid. It has no way of doing that. No way of saying that's not a protocol I know. If I change it into all zeros, let's see what that does. It says that's NTP. There's no way that's NTP. It's nothing like NTP, but it absolutely has to give me a result, and it has to be something that falls within the set. I hope that helps you understand why you cannot use a decision tree or a random forest classifier for anomaly detection. It doesn't mean they're not useful. So in this episode, we went through pulling out the problem, getting the data, reformatting the data, and turning it into a decision tree. I didn't load up the random forest, though. So in our next episode, I'm going to tackle something that is not a cybersecurity problem. Instead, I'm going to do a very simple computer vision problem, less for the computer vision, but much more so to be able to compare the performance of a decision tree versus a random forest and distinguish what a random forest is, or what makes it different and why it tends to perform better. Now, again, if you've enjoyed this live stream, please click on the like button, click on the follow button, subscribe to the YouTube channel, whichever makes sense. And if you do have additional thoughts on other things you'd like to see covered in this live stream, let me know. I will be taking both the training data that I've used here and the notebook that we've worked out so far, and I'm going to put that out into the repository. And we're going to continue to do that for all of the episodes as we move forward. If you have other questions or other kinds of problems, feel free, drop them in the chat. Reach out to me over LinkedIn if you're not currently connected. Maybe you're watching this as a recording, or add it to a comment on the YouTube channel. And we'll see if I can get back to you and also add more stuff in that you'll find useful for working with your data and solving cybersecurity problems. I do want to remind you folks that if you are interested in the 595 course that soup to nuts teaches you everything you need to know to put these tools into a toolbox and be able to solve your problems using data science and machine learning, the Orlando conference begins next week and is already sold out, has been actually for weeks, but there are a couple of more events coming up. There's one coming up in London in just a few weeks now. That one is going to be offered as a live stream and in person. Now, I'm not going to be flying to London because that's still a little bit dicey right now, but there will be people sitting in a room participating in the class live. It'll be streaming to that room and additionally streaming out over the internet. So that's a possibility depending on your time zone. There is also an event happening in December that will be in person and a live stream. So if you'd like to come to DC and do this in person, have a look at Sec 595 that's happening there in DC. If you'd prefer to stay with the live stream, which personally, you know what? If I had my option, I think I'd rather just stay home these days. But if you'd like to do that, you can still attend, at least attend virtually, the DC conference where we'll be in person. And we've got everything set up so that you can still fully participate in the class and pose questions and everything else. Otherwise, thank you very much for coming to the live stream today. I look forward to any feedback or comments you have. Please have a wonderful weekend, and I'll see you in about 2 weeks.